Okay, today we want to go ahead and talk about parallel and perpendicular lines. So for parallel lines, what I do is I use this little symbol right here. That just kind of helps me apply parallel and not have to write the whole word out all the time. And you'll use that more in geometry. Parallel lines are always placed the same distance apart. Two lines are parallel if they have the same slope and different y-intercepts. So vertical lines are parallel to each other, horizontal lines are parallel to each other. Okay, an example, here we have the exact same slope on both of these equations. Okay, the exact same slope. The only difference is their y-intercept has changed. So if we were graphing this, I'm not saying that you have to. Here would be the y-intercept of 4, approximately 2/3 of the slope. Here would be the y-intercept of 5, same slope of 2/3. So perpendicular lines. Those are lines that form a right angle. That's our symbol for perpendicular. Two lines are perpendicular if the product of their slopes is -1. So the product of two numbers is -1 if one number is the opposite of the reciprocal. Okay, this is called a negative reciprocal. So here we have two examples. I have 2/3 x plus 4. So here's my slope of 2/3. And then here's my slope of -3/2. The reciprocal of 2/3 is 3/2. And then we make it negative so we can multiply. Here we have 2/3 times -3/2. And basically we have 6/6 or -6/6, which equals -1. So here we have to find the slope of a perpendicular line. First, write the slope of the original line as a fraction. So even if I had a slope of -6, I would write it as -6/1. Then it says flip the fraction by putting the denominator over the numerator. That's our reciprocal, 1/6. Okay? But now it says change the sign of the fraction. Since the sign of this fraction is -1/6, what I want to do in step 3 is just make it 1/6. So I'm going to end up multiplying -6/1 times 1/6, and I get a -1. So what you should do is you should use point slope forms to write lines of equations that are parallel and perpendicular if the line has to go through a certain point. And we definitely are going to use this rule on the second half of our notes. But here all we're doing is we're saying write two equations in slope-intercept form for the line that passes through the point and is parallel or perpendicular to the graph of the line. Here all I have is a graph of a line. So in order to represent the line that is parallel to this, I would say y equals, I'm keeping my slope of -3x, and I just changed my y-intercept, and here I'm just going to change it to 5. To represent a line that's perpendicular, here I have -3/1, and I want to multiply it by its reciprocal of 1/3 in order to get -1. So it's going to be y equals 1/3 x plus 10. Okay, I'm going to leave that plus 10. I'm not going to change my y-intercept. For here, I have for my parallel, keeping my slope, y equals -1/5 x minus 2. For my perpendicular, I'm going to say y equals 5x minus 9. All right. So again, I have -1/5. If you're not sure how I got that 5x, -1/5, I change it to 5/1. To multiply those two, that would have to be positive in order to get a -1 as an answer, and 5/1 can just be reduced to 5. All right, let's look at the next page. This is where that note where it says you should use point slope form. Let's go ahead and write that point slope form here. Here's where we're going to use that point slope form. So For this first one, what we're going to do is we have the equation y equals x plus 4. So I'm going to start with point slope form. Y minus y1 equals m times the quantity x minus x1. The first thing I'm doing is I'm working on the parallel. So now I have my point, 3, negative 2. So y minus negative 2 equals, the slope is 1 in my equation up here, okay? My slope is 1, so it's going to be x minus 3. So now what I'm going to have is y plus 2 equals x minus 3. And now I have the equation of y equals x minus 5. And so what that basically is saying is this equation, y equals x minus 5, is parallel to the original equation, and it also goes through the point 3, negative 2. Now, to go ahead and do perpendicular. Again, I'm going to start with point slope form. That's why it was important for us to know point slope form. Y minus y1 equals m times x minus x1. Okay, so I have y minus negative 2 equals negative x. Oh, let me start off with this, okay? Y minus negative 2 equals, now since I'm doing perpendicular, okay, it's not just going to be a slope of 1, I have to do the opposite, and so it's going to be negative 1 times the quantity x minus 3. So now I have y plus 2 equals negative x plus 3. So I end up, the equation for the line that's going to be perpendicular is going to be y equals negative x plus 1. My slope, remember, I had to change that to be the number I can multiply to 1 to make negative 1. That just happens to be negative 1 in this case. For my next problem, okay, I have the point negative 2, 3, and y equals negative 3/4 plus x. So I'm going to start off with, so the first thing I need to do is I need to start with point slope form again. So I have, for my parallel, I have y minus y1 equals m times x minus x1. Substituting my values in, I have y minus 3 equals negative 3/4 times x minus negative 2. So we know that that's going to be plus positive 2. So I have y minus 3 equals negative 3/4 x minus 3/2. Okay, so basically what I just did is I multiplied 2 times negative 3/4 and I got negative 3/2. So I end up with the equation y equals negative 3/4 x plus 3/2. That's the equation of the line that is going to be parallel to this line right here. Okay, see, the only thing that changed was my y-intercept, just like our rules for parallel lines show. Now perpendicular. Okay, the original equation is showing us that it has a slope of -3/4. So I need to have the reciprocal, the opposite reciprocal of 4/3 when I put it into point slope form. So it's going to be y minus 3, just like we had before, y minus 3 equals 4/3, that's my new slope, times the quantity x minus -2. And of course, that's plus positive. So now I have y minus 3 equals 4/3 x plus 8/3. And if I go ahead and add 3 to both sides, I end up with y equals 4/3 x plus 17/3. And that's going to be the equation of the line that's perpendicular to this original line up here. Thank you.